Investigate horizontal transformation. Here we'll take the help of square root function and then try to understand the transformation. Identify the parent function f of x. As I said, it is a square root function, right? Now we'll see how to identify it. Write the equation of the transformed function g of x, that is your transferred function g of x. How are the points in the two graphs related? Now to find what function we are dealing with, it's a good idea to check some points, right? Now, and then that will give us an idea of how these points are related. So first is, let's analyze f of x. These are good points right there at the crossing of x and y, right? So let's list these points. So on f of x, we get points as 0, 0, and then we have 1, 1, and we have 4, 2. Now let's see the relation between these points. So it looks like a square root function, so we'll just straight away check with it. Square root of 0 is 0, square root of 1 is 1, and square root of 4 is 2. And therefore we say f of x is actually our function square root of x, right? So that is how we are getting our function as square root of x. So we say parent function is f of x equals to square root of x. Now let's write the equation of transformed function. So, and we also need to understand how the points get transformed. So we notice one thing about these two graphs. One is they are kind of similar, right? They have the same shape and they're congruent too. If you just flip and put it, they are kind of congruent too. But there's one difference here, that this graph is moved, right? So there are two things which we note. First thing which we note is, there are two things which we note. First thing which we note is reflection on y-axis, right? So it is horizontal reflection. On y-axis. Second thing which we note is this translation of one unit towards left. So it is translation. One unit to left. So I am trying to economize on space. So it is translation of one unit left side. So these are the two transformations which we notice. Now both these transformations are really affecting x points, right? Let's compare the points now. So if we see some points on this graph, so we say, well, this point is 0, 0, and this point is 1 and minus 2, and this point is minus 5 and 4. So let's write down these points which we notice on our function g of x, right? So what do we get? So on g of x, we notice that the points are, here we have minus 1 and 0. So the 0 has moved one unit to the left, minus 1 and 0. And then we have minus 2 and 1. And then minus 5 and 2. So if you compare your original points and the image, we call them image points, right, on the transformed function, what do you notice? The y values are same, right? Y values are same. That means if I take xy as my point on f of x, then when we transform it to g of x, then what is happening to points? My y points are same. So y points remains y. There's no change in y points. 2 is 2, 1 is 1, 0 is 0, right? What has happened to the x points? They are kind of minus and further minus 1. So it is like when you multiply by minus 1, you get minus 1, but it is minus 2. So the x points, you get minus times the x, and then again you do minus 1. So that is what is happening to the x points. So that is the transformation which takes place as far as the points are concerned. So how are the points in two graphs related? So that is the relation of points. So let's say relation of points. So this is a relation of points on original function to we'll say image. Transform function, right? So that is how the points are related for us. Now, from this type of relation, can you give me the equation of the function? Write the equation of the transform function g of x. So let's get back to the very first question, right? So we have answered this one, we have answered this one, now we are here. What is g of x? Now since we see that y values do not change, that means the change is only inside the function. So we can write g of x is equals to, nothing is happening outside g of x, right? That means we are not having vertical stretch or compression, nor do we have any vertical translations, but inside we have huge change. So what is the change inside? Inside change is that our x values are getting reflected, so we have minus of x. Second, what changes there? That they move. So if I reflect this, let us see, if I reflect it, then what do I get? If I do this transformation of reflection, then this point will come here, the other point will come there, right? So the reflection will actually be a curve which is kind of like this, right? So that is reflection. So once I do reflection, after that what am I doing? After that I am further moving 1 unit left. Do you see the second step? Moving further 1 unit left. 1 unit left. That means plus 1. So that gives me the transformed function g of x. Correct? So that is plus 1. But writing like this will make it wrong. Important thing here is you have to put this bracket here. So whenever we have a transformation which is horizontal in nature, we have to see function as a whole. Remember that part. We have to see function as a whole. So now you see this minus factored out tells you that this whole function has actually reflected on y-axis, and then plus 1 says that you moved 1 unit to left. That you moved 1 unit to left. So that is how it is to be seen. And let's try to put some values and see the result. If I write x as minus 1, minus 1 plus 1 is 0. So square root of 0 will be 0. So we get this. If I write minus 2, minus 2 plus 1 will be minus 1. Minus 1 times minus is plus 1. And square root of plus 1 is 1. Do you get it? If I write minus 5 here, then minus 5 plus 1 is minus 4. Minus 4 times minus 1 is plus 4. And square root of plus 4 is 2. So you can get all your points. So that is how we tested it, right? So good way is, once you write the equation, always test it. And if you get the same points, then you know your answer is correct. Do you get it? So these are the steps to be followed when you're trying to write equation from the given graph, right? So let's understand all these steps. First, observe. When you observe, you see two types of transformations. One is reflection, the other one is translation, and both are horizontal. So no change in the y values, only the x values are changing. The change in x values is that x values get multiplied by minus 1, and then you take away 1 to move them further left. This change happens only if you write a function which is kind of like this. Do you understand? So in general, that is how you have to go about to get the answer, right? So I hope it helps you to understand. Now if I have to write a general transform function which could be here, but the values could be different in this fashion, then I could write f of x. Let's say a function is f of x, and change of this function which will kind of reflect this kind of reflection g of x could be written as f of, nothing happens outside, but inside we have minus. This minus makes reflection on the left side, and inside x, and since it is moving leftwards, we write x plus something p, for example. Okay, when it is plus inside, that means you are moving left. That means left p units. P units. You understand? But if you have minus here, that means right those number of units. That in general will help you understand this situation. So this is generalization, this is specific to our given example. So I hope you understand now how to incorporate translations with horizontal stretch and compression. So that should help you. And I've taken specifically example of square root function. Now for you as an exercise, I will write you to write domain and range. So write domain and range for both. Domain and range for both. That means I want you to write domain and range for the original function f of x and for the transformed function, right? So original function, domain and range is what? Domain is x is greater than equal to 0, and the range is for the original function y is greater than equal to 0. That is for the original function. And how about the transformed function? So this is for f of x. Now how about g of x? In g of x, as you can see, domain has moved to -1 and leftwards, right? So x is less than equals to -1, but range remains the same, since there is no change in y values. In x values, we saw a change that first it gets reflected, right? So every point that is less than instead of greater than, and it moves -1, less than -1. Do you understand? So that is how we can correlate all these things, and I think now all have come together and you have understood. Thank you. If you still have problems, do write to me. I've given my email address, and then from there we'll take it up. Thank you and all the best.